real exam questions. This is question 12 and it deals with struts and ties. You can also determine reinforcement using a strut and tie analogy. When is it appropriate to apply this? Show 3 different types of constructions that you can only solve with a strut and tie analogy. And what are the geometric conditions of each type of construction? To answer the first part of the question, when a plane before loading is no longer a plane after loading, it means that you are in a D region and not in a B Bernoulli region. The classical method of reinforcement calculations is no longer valid, so you must then use compression struts, tie rods, and knots to transfer the forces. First, take the example of a deep beam. A deep beam is, for instance, the wall of an escalator with a height h, and the wall is supported by 2 foundation piles with a distance of L between them, and it's loaded by a uniform distributed load. Half of this load goes to this compression rod, and the other one is going through this. So the black continuous line is compression. The dotted line or dashed line is tension. So those 2 compression threads come together, and then they find out, or they will find the support, and it's 2 inclined compression struts. When they come close to each other, you have another compression strut. When they are diverging, you have a tension rod or a tension knot. This you can solve it simple by some very simple equations, and the geometric conditions is when the length or the distance between the 2 supports must be smaller than 3 times the height of the beam, height of the wall. Otherwise, you will have simple bending. Then you have the case of a corbel. For a corbel, the forces FED and HED acting on the support here. Then the resultant of FED and HED follows this blue line. When you reach the reinforcement on the top of the corbel, then you have the tension rod. Then the compression rod will directly divert the forces to the column in this strut. But because of this strut, it will develop 2 other compression struts, and then the 2 others coming again together to the board. And when 2 struts are diverging, then you have also tension rod. So you have 2 tension rods. In fact, this system is internally in the corbel, and this is the main action, let's put it this way. The conditions are that the distance AC must be smaller than Z0, and Z is where the main compression strut reaches the sides of the column or wall, and then the distance to the center of the tension rod. A third example is a foundation block. You have, for instance, a foundation block on 2 supports with a distance of L. Foundation block has a height or a depth of H. It's loaded by a column, so the forces are directly transferred to the foundation, that are the compression struts, and then you have a tie rod or a strut in tension on the bottom. The conditions for L over H is that L must be smaller than 3 times H. If not, then you can calculate this as a normal beam.